All right, welcome folks. The first discussion topic today was mine about parallel resharding design, following up on earlier work from Mengwan Liang. I had been thinking about design stuff for this. He opened a PR this week, and so I used that as a place to kind of dump my thoughts on it. So the agenda has a link to that discussion. I'm mostly trying to decide whether to go with C++20's stackless coroutines or the existing coroutines that we have with optional yield. So I tried to break down what was missing for both versions. I think either way, we're going to have some extra work to do. With stackless coroutines, I think the biggest missing piece is writing the bucket metadata. Since metadata has a pretty complicated model that involves caching and watch notify, I'm not really eager to duplicate all of that code so it can be called within coroutines. And that's kind of just a general concern that I have with adopting C++20 coroutines, is how to manage the complexity of duplicating code. Similar issue with adopting NeoRados in place of LibRados, I think. So, I mean, with the existing coroutines, we have the abstraction of optional yield, so that code paths can be called from stackable coroutines or synchronously. But with C++20 coroutines, the function signatures have to be different, and so we don't really have a way to write functions once that can be used both ways. Do you guys have any thoughts in general about this? Adam, maybe really just looking for a general strategy to start migrating stuff without duplicating a bunch of code.
Do we actually have functions? I mean, in the context of the specific area you're touching, do we have functions that are called both with the null yield and with the actual yield?
Sorry, say again?
My question is, in the code area that you're touching, do we actually have this issue of functions being called both with the null yield and with the real optional yield?
Yes, pretty much all of the metadata system takes optional yield.
No, I understand that it takes optional yield, but is it ever invoked with a null yield?
Yes. Front-end requests will have a yield, but RGW admin commands won't. It's also
that is actually one of the reasons why I want to get rid of all the non-blocking out, all of the blocking I/O, and turn Rados GW into a coroutine one of these days, just so we don't have that be the case anymore.
But my question is not in general for all of our calls. The specific calls you're talking about with the metadata sync, right? You were asking about these, right?
With writes to bucket metadata, yes. We're also prototyping a new metadata sync, and we'll have the same issue there.
So in metadata sync, it's also could be invoked from RGW admin, you're saying?
Well, the current code is, but we don't have a C++ 20 coroutine version of that stuff. And I mean, naively, I think we would just duplicate that so that there's a C++ 20 coroutine version and the optional yield version. And it seems like there's just going to be inescapable complexity from code duplication here, and I'm not sure how to manage that.
Do we really need to save synchronous variant of these functions, or maybe we could just make everything asynchronous?
Yeah, that's definitely an option. I think that's what Adam was suggesting. Anything like Rados GW admin that is synchronous can create a IO context and spawn stuff and wait for it to finish.
If this is possible, we
and it's not
can. Okay.
I was going to say, Rados GW admin already does spawn an IO context because we need that to get anything in store to work.
That's
because
true, yeah.
if we will replace everything with awaitables, it can be done right now. I don't see any reasons why it cannot be done, because Rados async operations use async initiate, and it can produce any kind of completion token, so it can be integrated with awaitables, even though other parts of Ceph are not ready for this.
Yeah. Sorry, Adam, did you still have a point?
Oh no, I was just going to say Rados GW admin already has an IO context. Like it's already halfway there because we need it for we need it that way for the driver to work.
Yeah, that's true. But like if a Rados GW admin command wants to make some calls and wait until they complete, I don't think that the global thread pool would really give them a way to do that.
Oh yes, that's true. Sorry, yes, you're correct.
So for cases like that, I would just put an IO context on the stack and run stuff on that.
Yeah, you're.
As I remember, there were difficulties when you want to put asynchronous task into the interface. I had to make some async initiates that in the base class that calls some specific function that spawns the coroutine and returns it, because for some reason you cannot spawn awaitable from the derived class. It's a little bit complicated, but I can recheck it. But as I remember, there were difficulties with that. But and we have everything hidden behind the interfaces.
Yeah. So like making all of our GW async only, I do want to see that eventually, but it's a huge project, and I'm not sure how we can get there incrementally. And I think we still kind of have the problem of some things wanting to use stackful coroutines and others wanting to use stackless, unless we just convert everything to stackless. You mentioned that ASIO has the async initiate thing that takes a templated completion to handle both, but that's right? That requires templates, and so it doesn't fit in interfaces, and it's complicated, and so we don't want all of our RGW code to have to be templated like that.
Yeah, awaitables work in the interfaces. They can they use type erasure to hide what's inside of them, so it's fine. But yeah, it probably should be done in one change, because I don't know any way you could spawn yield context in the middle of asynchronous operation.
Yeah, you're right that awaitables can be used, like coroutine, C++20 coroutine functions can be virtual, so used in interfaces. Another way to do that more generally without templates is to use the type erased any completion token. So that could be potentially an option if we want to support both stackful and stackless.
Why would we like to do that? I mean, what's the value?
I think that's a good question. I've been thinking that there are things that fit well with stackful, like the front end coroutines. But we could potentially convert everything to stackless. I still don't have a really good feel of the performance characteristics of stackless coroutines, though. I know that they do require dynamic allocation for every coroutine's frame.
Yes, for every function call that returns awaitable, you have to make an allocation. But it can be made a little bit cheaper with custom allocators, but it's complicated stuff. You can attach allocator, custom allocator to the first coroutine when you create it, and then Azure is going to use it.
Yeah, and I think that, I mean, your concern is about the front end, right, where the coroutines are short-lived. But
Sorry, I would say that the front end coroutines are long-lived. There are generally going to be lots of IOs required to satisfy a single request.
oh, okay, so if you consider them as long-lived, what kind of coroutines are short-lived? I mean, the other ones are kind of background work, which isn't even like doesn't end almost ever. The front ends are like per request, so the request ends relatively quickly. But if you're not concerned about these, then I'm not sure why.
They are not per request, they are per connection, because one coroutine can handle multiple requests if they are done in the single connection.
Yeah, but worst case is that you're gonna get one per request, right? Because in theory, the clients can just open a connection, send a request, and then close the connection.
Yeah.
They are cheap enough to construct for such a request. It takes several milliseconds, so it's not a big deal.
And I think the good thing about the front end is that we know exactly how many we can have in parallel, right? So if we build our custom allocator, then we can just allocate all of them one time and that's it. It's not really dynamic. Like we decide what's the maximum number of concurrent connections we support, and that's it, right?
I mean, theoretically, the way that it works now is that we will accept every connection as it comes in and spawn a coroutine, but then we'll only process max concurrent requests in parallel. But with some changes to how that works, we could limit the number of connections we'll accept at a time and be able to pre-allocate that.
Okay.
I don't think it's ever going to be a bottleneck here. Rados operations takes much more time, and maybe if there are a lot of connections, we can get out of memory errors, but it's not something that would usually occur.
Yeah, with these stackful coroutines, there is some overhead allocating the stack because we're using mmap and mprotect system calls on it. And we did see something like 2 or 3%. I forget exactly. Mark Nelson measured the difference. So it's there, but it's not huge. Another comparison between stackful and stackless, I think, is that context switches are more expensive with stackful because it has to change the stack pointer also.
Probably yes, but I think it's going to be negligible. What are we trying to achieve with this transition? Because stackful coroutines now are relatively easy to use. Not the C++20 coroutines don't bring anything new to us that we don't have.
So one of the goals, I think, is actually to replace the third variant of coroutines that we're using currently in multi-site syncing. This is an old framework that is not easy to use for various reasons, and also kind of a barrier for anyone trying to do anything, fix bugs and so on with multi-site syncing. So this is really the main reason to switch to something else. And the discussion is what to switch to, whether we want to switch to the C++20 coroutines, or do we want to switch to our existing coroutines?
Yeah, thanks. And the multi-site coroutines are stackless themselves. And I think that was a good choice. Yuval, you were asking for examples of short-lived coroutines, and I think that's where we see a lot of them. Essentially, you know, their multi-site has some long-lived coroutines that are looping over log entries, for example, but it will spawn a lot of concurrent work to process that stuff. And most of those coroutines are just, you know, make one HTTP request or read one Rados object. So we spawn a lot of things and they go away after essentially one I/O.
Co-spawn is very expensive. That's something I can say for sure. I have measured it. It takes several hundred microseconds to spawn a new coroutine. I would prefer if if I would implement it, I would use channels from ASIO. One thread would push new events into this channel, and other coroutines, long-lived coroutines, would pull from there and process them. So it's relatively easy to understand. The channels are straightforward and much more efficient than spawning individual coroutines for individual Redis objects.
Interesting, thanks. And the hundreds of milliseconds, is that what you said?
Microseconds.
Microseconds was for C++ 20 coroutines co-spawn?
Yes. Creating the coroutine, spawning it to the I/O context, and then it getting to run.
Okay, wow.
In our code base, we used co-spawn only to launch some first coroutines or to spawn some long-lived tasks that would do something for several seconds or even minutes and then go away.
Okay, that's good to know. In terms of reshard specifically, we're essentially going to be spawning a coroutine for each source shard of the bucket, and those would be alive on the order of seconds to list all of the entries from the particular shard. So I think it would still make sense to spawn new coroutines for that.
Yeah, I think it's fine.
But yeah, I'm still trying to get back to the issue of if we can't convert everything in RGW to these stackless coroutines at once, then how do we manage the migration from one to the other?
I think what we should probably do is, like we were saying before, get rid of the places where we have to have a null yield right up top. And once we can get rid of those, we could even do something like switch from optional yield to just plain old yield, which would solve the blocking problem on its own and give us a lot of what we want anyway. And then it's just a matter of where we want to define our boundaries and move them. But I feel like the first thing would just be getting rid. But I feel like the first thing would just be getting rid of all the places where we have a null yield, where we don't need one. Well, getting rid of all the places where we have a null yield, period, I guess. Like Rados GW being the main one. Or Rados GW admin, pardon me.
Another disadvantage of C++20
Okay, but how
coroutines.
does that help us start converting stuff to C++20 coroutines?
Oh, well, the way it helps is that C++20 coroutines don't have an analog of null yield. Like for a C++20 coroutine, we don't have a block. We just don't have an option. So so as long as Rados GW is there, it seems like either we have to do an explicit blocking call, like I do an explicit block with the coroutine, like I do a couple times in some of the startup code, or we can just write it straight through, I guess. Other than that, I guess the main thing would just be having an easy calling convention to call from one to the other.
Yeah, I'm thinking like the system object interface, for example. How do we write one version of that works for both, so that we don't avoid duplicating?
in all honesty, I would simply want to go system by system, do the system object stuff, make rewrite of the C++20, put an interface, put a stackless adaptation, or put a stackless adapter on top of all those, and just work outward from there. What subsystems called into it? Try to switch subsystem one by one to all coroutines. Eventually, we'll just meet up at all the boundaries, I think. But as long as we go subsystem by subsystem and not function by function, I think it should work pretty well.
Okay, so say that we convert the system object thing to C++20 coroutines, then RGW requests on stackful coroutines would use co-spawn to call into the system object?
I believe so, and then we could go up the stack. We could say, look at the S3 requests where we're using optional yields, go up that level, and just keep on going that way, would be my guess. The other option, I think, might just be top-down, where we switch to you. Well, no, top-down, we'd basically just be sticking in a spawn at the top of every call. So I don't think top-down makes sense. I think bottom-up, subsystem by subsystem is probably the most tractable.
Yeah. Okay. I mean, that's paying some overhead to convert from one to the other, which hopefully will be temporary, but just judging by how long the async refactor has been in progress, temporary is...
Sorry, I keep getting pulled onto other stuff. I need to actually focus on that properly.
Yeah, I mean, it's
pulling
really
myself onto other stuff. I'm sort of volunteering for it, so it's not like I can blame anyone else.
Yeah, I don't think it's anybody's fault. It's just RGW is massive, and so none of these are small projects.
But I basically don't think there's a way that we can do it without paying a little bit of an overhead cost along the way. I feel like if we don't do that, then it won't get done. And if it doesn't get done, we're basically just going to end up even more fragmented. Because right now we have essentially 3 coroutine implementations.
Yeah.
I think it's going to be complicated to do it system by system because coroutines and yield context does not play together. We use concrete asynchronous types in the interfaces right now. And ASIO uses some template magic to make different asynchronous mechanisms work together. And the redesign is going to be huge. Probably, if you're going to do it system by system, this system should implement some function that is going to take the base completion handler, any completion handler that ASIO provides, and convert it to some specific one and call it. For example,
if we do that, everything in RGW will end up header files. Like if we do that, we basically end up with header-only RGW.
Well, the type erase any completion handler helps with that, but it still means that we have to
completion handler. All right.
Yeah, it still means that we have to convert systems that look synchronous now because they're coroutines into async internally, which is
I need to implement everything in the header files. You can implement only this trampoline function that calls a specific implementation, and it can be done in any asynchronous paradigm.
So you might. So you might, for example, suggest something like, all right, I think I might see what you're saying. I'll have to roll it around in my head.
Okay, well, this has been really, really fruitful. At least in the general case. For Reshard specifically, I want to find a way to make progress on this in the shorter term, which might just mean duplicating things like rights to metadata, or sticking with stackful coroutines for now and converting along with other things later.
I feel
What do you
like
guys think?
I feel like if we want to be pragmatic, I think this is probably the way to go, because I mean there is concrete value from doing that, and it also it's going to be more tangible. It's going to happen. We don't need to think about a process that might span more than one release and all the consequences of that. So to me, this should be the path. And if we decide to do a more radical change later on, we'll have to figure out how to do that. Maybe do the bottom up work as Adam suggested, but again, because it's so different, the coding looks so different, then it's a different question. I think to achieve our initial goal and for example with resharding or anything else with multi-site syncing, I think we should stick to what we have.
Well, I'm not convinced in the case has been made we shouldn't be continuing with the work Adam started for multi-sites. In fact, I would disagree with that.
I don't think anyone's suggesting that. I think for multi-site, people definitely want it.
Well, I'm just responding to a statement that you've all just made.
Yeah,
and I don't agree with it.
Well, it doesn't sound like maybe what I'm saying doesn't sound as the best option, but if we want something to actually happen, then it might be the way to go.
I don't understand that statement either. Work is being done. The upstream process shouldn't be blocking it. I agree with Casey with the first part of your statement that we should be helping Casey get the project, the restarting project done using what makes the most sense now. But we shouldn't be finding enormous obstacles in the intermediate future and saying let's not modernize the code.
Yeah. I do still think that stackless coroutines are a good fit for multi-site. We have a prototype started for metadata sync there, but we're going to eventually have to work through a lot of these issues, like what abstraction do we use to read and write metadata, for example.
Yeah.
Okay, well, do folks agree that we should stick with stackful coroutines for reshard for now? If so, I can update the design for that.
If that's what they are, and there isn't
I mean, I just want to understand. I mean, have you already got work in progress to do something different? I mean, I'm really a little bit. If that's the most straightforward way for you to continue, then then I would agree with that.
I did start prototyping C++20 stuff, and there is some code that I wrote for the metadata sync prototype that's useful here, specifically around renewing the lease that we use for reshard also. But we can implement similar things with stackful coroutines.
I don't know. I'm kind of on the fence. I'd like to talk more with you, Adam. Maybe offline.
Yeah, with that one, I'm basically happy with whatever you think is the quickest way forward, honestly. But I'd be happy either way.
Again, I guess that's my default position. But I'm not yet sold that we should avoid the framework we've been working towards. And if we want it to be quite different, the way Artemis seems to be suggesting, that if it's more efficient, that might be attractive. But I don't want to get stuck where we are.
Yeah, Artem's comment about channels in particular, I would like to follow up on, and look through the metadata sync prototype that we have so far and see what we could improve with that.
Yeah, if it has combinatorial advantage, I'm for it.
Okay, well, any more thoughts on this topic? See that Sina has a couple others that I want to make sure we leave time for. Okay, let's move on. Sina, you are asking about the pull request to add essentially cross-region replication.
Yeah, I just discovered another possibility to make that pooling a bit of more inexpensive. So I just wanted to see if anybody has any thought on it, because that also addressed another issue about having multiple rules per bucket replication. Currently, from AWS perspective, you can only replicate an object to a single bucket rather than multiple buckets. But I guess with the current design we have with sync pipes, you can have multiple destinations for a single object. So that's kind of like an incompatibility right now, and that was addressed via the priority field. That now it's being not respected by RGW because of probably that reason. But so what could we proceed with that? Should we adopt that, or do you want to have the incompatibility?
I'm not sure how helpful I can be. I'm not really familiar with the per bucket replication and the pipe stuff. I know that there are some just structural differences between RGW multi-site and AWS that are going to be hard to escape, but if there are concrete changes that you'd propose, then let's discuss with Shilpa in the PR. Does that sound good?
Yeah, sure. I just left my comment, so we can just follow up on that comment by comment. No problem. Thank you. And I read one more topic regarding the deletion process, just because I don't know if that is a regression on Squid right now because it's not working, so we cannot delete a bucket from another zone group. Can we define a process for the deletion? So maybe, I don't know if I could implement that, or is anyone want to implement that to fix it? Basically, I see that as a bug currently.
So the problem is what? That if you have multiple zone groups and delete a bucket on the zone group that owns it, and we forward the deletion to the master, it fails there, or is it something different?
Exactly. So because there are no indexes on the master zone group for the bucket that owns by a secondary zone group, the master returns 404 and the deletion would stop because forward to master is not successful.
I see. Yeah, I guess that we would want to avoid the empty check on the master zone.
Yeah.
In that case.
Yeah, that could be an option, but we have that in multiple functions. I mean, one is in RGW up and the others are on drivers as well. So we need to probably forward a check variable, some Boolean to ignore these checks for if it was a forwarded request, something like that. That's what the only thing I could come up with. But it just, introduced an argument to many functions. Not sure if it's a good practice or if there anything else.
I mean, potentially you could look at the buckets zone group and compare with the local zone group in the driver as a way to avoid passing extra args.
Do you have any link to a function code? Because I've never seen a local zone versus that one in the driver. That would be great.
Well, the Rados driver has the zone service, which you can ask for the current zone group. And we've been converting that stuff to the site config, which has a get zone group function. So there are two ways to query what the local zone group is.
Okay, that's a good trick then. I'll try to find it, but if you could also point it, that would be great. But okay, that's a good hint. Okay, that definitely helps to not pass an argument. Okay, thanks.
Great, and I did see that Shilpa opened a PR to re-enable our multi-zone group tests. Getting those running again would be a great way to test further changes here.
Yeah, definitely. I'm just looking forward for the result as well. So that would be great. Thank you for the interest.
Yeah, without test coverage there, it's hard to stop ourselves from breaking things.
Yeah.
Thanks, Sina. Anything else?
No, thank you very much.
All right. Any new topics for the agenda?
I think that we can a little bit redesign all this multi-site thing by implementing multiple Redis pools for a single RGW instance. So it can, with some additional metadata, it could send data directly into one Redis pool or another, and all this synchronization stuff won't be necessary.
Sorry, are you talking about one RGW hosting more than one zone so that it could do like...
Yeah.
What kind of use cases would have two zones on the same cluster that need to replicate stuff?
It won't be a single cluster. It will be multiple Rados clusters and probably multiple RGW in different regions. And through this RGW instance, you could access both Rados pools, and the synchronization will be much easier because you don't need to sync S3, which don't have such mechanisms. You could just sync through Rados that has them. you know, like implementing like Amazon does it, for example.
I guess I'm not familiar with an example. I mean, right, we could potentially use a Librados client to across some wide area network
Yeah, that's
to
what's
read
being
and
said
write
here.
directly to another cluster, but I'm not sure why that's better than HTTP requests.
Well, I think it has other problems.
Yeah, probably I need to think more about this, but on the first look, it looks much easier to accomplish all of this. For example, writes from multiple zones into the same bucket would be easier because they are just going to be redirected to the another zone. And for example, can be replicated. Okay.
But I think the whole point about the existing mechanism is that we don't want to bear the latency of cross-zone communication when we're doing operation on a specific zone. So this is really the root of the design that we have now, which means that everything is done asynchronously in pooling from the other zone. Because
Okay.
zones could be many milliseconds, hundreds of milliseconds apart from one another.
That makes sense, yes.
Yeah, and I mean, we do have some redirect logic across zone groups instead of across zones. That might be similar to what AWS does with regions.
Okay, thank you.
All right, anything else for today? Thanks all. See ya.
Thank you. Bye.